Right, hello guys. So do you have any questions about homework? I can answer any questions you have before we get started. Any questions?
No,
Oh,
but this time doing this one.
wow. How many Rubik's does Gavin have? I think he's brought at least 5 different ones into class so far. All right, if you just came in, are there any questions you have about homework? If there are any questions, I will be able to answer them. All right, so it seems like I have enabled the public chat. So for this class, I'm going to test you guys. I'll have it open so you can chat if you want, but still you have to put math before the chatting. All right, so let's not spam the chat so much. Okay, if I see anything that goes too wild, then I'll close it again. Okay. So if you just came in, are there any questions you have about homework? All right, that's cool. So I hope you guys understood how you would do that challenge problem at the end, because I wrote like 1 page of solutions there. Okay, it's 8 o'clock for me. So how about I share my PowerPoint right now, and maybe we'll wait just a few more minutes for people to trickle in. So if you can read the screen here, we are talking about perimeter and area. All right. Oops. So let's wait just a little longer.
Yeah, I solved the whole thing once.
What? That's fast. How do you do Rubik's Cubes? I'm so bad at them. All right. So 801, I'm going to get started now. So this week we have perimeter and area. So the topics are obviously going to be perimeter, area, and then we're going to be talking about a lot of things about circles and curved things. We're going to be going through the perimeters and areas of circles and curved things like that. Okay? So I'm sure a lot of you already know what perimeter and area are. So this will be half a review and then half like more advanced topics. Okay? So let's get going here. So perimeter. All right, what is perimeter? Well, let me get out my pen here. So before we go on to what perimeter is, let's first talk about what length is, what a segment is. In math, when we have a segment is a short line with a set length, okay? This is called a segment. We make a segment by connecting 2 points together. In this case, we have point A and point B, and we've connected that, okay? So how do we name segments? how do I know that this is the segment that it is? How do I name it? Like with angles, we named it as like angle ABC. How do we name a segment? Well, how do we name a segment? We just write the 2 points, A and B, and we draw a line on top of them. So we would refer to this segment, we would call this segment AB. This is how we label segments. And how do we label the length of segments? If we wanted to say, oh, AB is 2, how do we label that? Well, we just write AB again, but without the line on top. Without the line on top, AB, this refers to the length of the segment, not to the segment itself, to the length of it. So AB would equal to 2. But AB with a line above it, that doesn't equal anything. That's just what the segment is. It's just like, oh, my name is Colin. This would be the segment's name, okay? So that's a segment. And something else we have in math is called a midpoint. And what a midpoint is, let me write that out. If you look in the word midpoint, it has middle, right? And that's exactly what a midpoint is. A midpoint is a point exactly in the middle of a segment. Let's label this M. And what a midpoint does, it splits the segment in half. Okay, so 1/2 on this side and 1/2 on this side. And these halves have the same length. Or, in other words, these halves are congruent. Remember that word, congruent. And how do we label congruent segments? We use these little notches to indicate that they are congruent. So a midpoint will divide a segment in half. So the midpoint of any segment is the point that divides it in half, and those halves are congruent to each other. So for example, if I had 2 here as the entire segment, then each of these small segments would be 1, right? 1/2 of 2. So now, with that out of the way, let's go on to perimeter. What is perimeter? Perimeter is basically defined as if we have some kind of boundary, if we have an enclosed space. I have an enclosed space. I have some space in here, right? I have created a loop, a space. And what's defined as the perimeter is the length of this boundary line. The entire length of this boundary. That's perimeter. We add up all the lengths of these. So most commonly, you're not going to see weird curves like that. You're going to see maybe a rectangle. As we know, rectangles have a set width and a set length. So what's the perimeter of a rectangle going to be? Oh, we have to add the entire length of the boundary. So we have L, W, L. So we have W plus L plus W plus L, or 2 width plus 2 length. So if you want to memorize this formula, this is the formula for the perimeter of a rectangle. But this is pretty much self-explanatory. You don't really need to remember this. So basically, perimeter is the boundary line, the length of the boundary around this area. We have some kind of area in here. We can put like sheep or animals in there, like if we were farmers. We have some area, and then the boundary, the length of that boundary is called the perimeter. All right, so that's pretty simple. Are there any questions? All right, let's go into these 1, 2, 3, 4 problems. So maybe I'll give you guys, how about 6 minutes? So if I don't reply to your chat, then that means you got it right, okay? Once again, if I don't reply to you, then that means you got it right, because there's so many I have to reply to. Sorry about that. And also, when you give me your answer, please note which question you're referring to. Is it question 1? Is it question 2? Please write that in. Once again, if I don't reply to you, then that means you got it right, because I have too many to reply to. Oops. Sorry about that. Seems like most people are going to be on the nap with the last problem now. All right. So if you're having trouble with the last question, my hint for you is to try to draw out a diagram. So one person's got it right. So in geometry, it always helps to draw out a diagram. All right, more people are getting it right now. So one more minute on these problems. All right, so I'm going to explain these problems now. So what is the perimeter of a rectangle with length 3 and width 4? Well, we could draw out a rectangle, of course. 3, 3, 4, 4. So what's the sum of all the sides? 3 plus 3 is 6. 4 plus 4 is 8. 14 units. Right? So that should be pretty simple. Now what do we have? The perimeter of a triangle is 36 units. The side lengths are in the ratio 3 to 4 to 5. What's the length of the longest side? Well, what do ratios mean? Ratios mean that one of the sides is 3x, another side can be 4x, the last side can be 5x, right? Because whatever x is, this ratio will be the same, right? This ratio will be set. So the perimeter means that we have to add all the sides together. So if we add 3x, 4x, and 5x, we get 12x, okay? So 12x is the perimeter. 12x equals 36. So what is x? We just divide by 12 on both sides. So x is going to be 3. So now, what's the longest side? Well, if we look at these, the sides have length 3x, 4x, and 5x. 5x is the longest side. So how do we find the longest side? We just do 5 times x. 5 times 3 is 15. Okay? So this is kind of a review of how to do ratios. So now, the third question. A triangle is equilateral if all its sides are the same length. If an equilateral triangle has perimeter 51 units, what's the length of each side? Well, if the triangle is equilateral, then all the sides have length x, right? So if we add all those sides together, we'll get the perimeter. X plus x plus x is 3x. And this will be equal to the perimeter, 51. Divide by 3 again. So this x will be 17. 17 units. Okay? So now for the last problem. The last problem is more of a problem about midpoints. Okay? So points B and C are on segment AD such that AC to CD is 3 to 1 and B is the midpoint of AC. If BC is 6, what is AD? Wow. That is too much for my little brain to handle. All right, so what do? Let me draw out a diagram to make things easier. So first of all, I know that I have some kind of segment AD. Okay, let's draw this pretty long. A and D. And points B and C are on this segment. Well, how do I know where they are? Well, let's use the second hint here. The length of AC to the length of CD is 3 to 1. So AC is going to be a 3x, and CD is going to be x, right? Because as you can see here, the length of AC is 3 times longer than the length of CD. So now we need to worry about B. Where is B? B is the midpoint of AC. So B is the midpoint of AC. So B is right here. And we'll label these congruent segments because it divides AC into 2 congruent segments. Okay, so what do these segments have? Well, 1.5x and 1.5x, right? Because it divides 3x in half. So now what do I have? We have one last hint here, which is BC equals 6, which means 1.5x equals 6. So what's AD? Well, AD is 4x. So we already know, so from now on, we can just solve for x and then plug that back in to 4x to find the length of AD. So what is x? We divide through by 1.5. Well, 6 divided by 1.5, how do I do that? Well, that's 4, right? You can do 6.0 over 1.5, okay? So x equals 4, so 4x equals 16. That will be 80, okay? So as you can see here, if there's too much information for you to handle, you draw out a diagram and you see how all the things play out. Okay, any questions? Cool. So now let's go on to area. So once again, we have some kind of enclosed space, right? Well, the perimeter was the length of the boundary of this space. We add the length of the boundary, right? So, but the actual space inside the boundary, how much space do I have within this boundary? That's what we call the area. The area is the space inside the boundary, okay? So for example, if I had a small shape like this, there's a lot less space inside this than if the rectangle were bigger, right? So in this case, this rectangle has a small area, and this rectangle has a big area. So how do we find the area of rectangles? Well, you might know already, if we have length L and width W, then the area will equal to W times L. So I think a lot of you already know this already, but if you don't, this is something you should remember. The area of any rectangle is W times L. So for example, if, I don't know, I had a width of 3 and a length of 5, then the area would be 3 times 5, 15 units squared. So why would I use units squared? Why wouldn't it be just units, right? Well, let's do something called unit analysis. So I talked about this yesterday in my physics class. So basically 5 is in units, 3 is also in units. If we multiply the word units by the word units, units times units equals units squared. So that's the unit we're going to use here. For any kind of area, we're going to have to use units squared. If this was 3 centimeters times 5 centimeters, then the area would be 15 centimeters squared, all right? So please, please, please remember that area is given in some kind of unit squared, okay? And the dumb thing is, when you go to school and you don't write this the correct way, they're gonna take points off of you. So please remember this, okay? So basically, that's all you really need to know for the problems I have, okay? So let's get going here. We have 2 problems here. So maybe 3 minutes for these. Once you get your answer, please chat that to me. One more minute. All right, so I'm going to explain these now. So for the first problem, in the diagram, the area of triangle, what is the area of triangle PQR? So what's that triangle going to be? It's going to be this guy right here, okay? So what's the area of that triangle if PSQR is a rectangle? So I haven't taught you the formula for the area of a triangle. So how would you solve this problem if you only have the formula for the area of a rectangle? Well, if you observe here, the line, this line cuts the rectangle in half, right? Because we have this area right here that is same as this area right here. So the line through the middle is cutting the area of the rectangle in half. So this triangle, the area of this triangle is just the area of the whole rectangle cut in half. So what's the area of the rectangle? 4 times 9. And if we cut that in half, we times 1/2. So what's that going to be? I just canceled, and I have 18 units squared. Okay? So you don't really need to know the triangle area formula for this problem. You just have to use good thinking to figure out that the line cuts the rectangle in half. So what is the general formula for the area of a triangle? Well, we did base times height, or width times length. So basically it's base times height, and we divided that by 2. Okay, so this is the formula for a triangle. For any kind of base, B, and any kind of height, H, and the height is always going to be perpendicular to the base. If we have these two components, the area of the triangle is always going to be base times height divided by 2. And this doesn't matter which base you choose. You can choose this base as B. It's just that the height in this case will be different. Its height will be this line. Okay, you can choose whichever base you want and whichever height that corresponds to that base. So in this case, it would be this this line. So you can do any combination of those, and you will get the same answer for the area. Okay. So now let's, from that answer, from that formula, let's now do the second problem. So what's the area of this triangle here? Well, this is a little weird, right? How do we know for sure that base times height is going to work here? We do have a height. We do have a base. And the cool thing here is that it doesn't matter the shape of the triangle. If I were to stretch this out really long, but the triangle still has a height of 8 and a base of 18, if I keep the height and the base the same, it doesn't matter however which way I stretch the triangle, the area is always going to be the same. Okay? So the rule of thumb is that if you have any base of a triangle and you take any kind of perpendicular line, and it's the height. You take any kind of perpendicular line. It could be anywhere. If you do the base times that line, that will give you the area of the triangle. So what will this be? It doesn't matter how much stretched this triangle is. It could be just like this, 18 and 8. These will have the same exact areas. So what's it going to be? 18 times 8 divided by 2, 72 units squared. All right? Are there any questions about that? All right, cool. So now we have 2 more problems. So how about 3 minutes for these as well? So if you're having trouble with the first problem, set variables for the length and width of Farmer Bob's field. So say Farmer Bob's field has length L and width W, and then use those same variables to represent Farmer Joe's field. Todd raised his hand. Do you have a question, Todd? Andrew raised his hand. Do you guys have questions? All right, one more minute. Okay, so I'm going to explain these now. So the first problem says that Farmer Joe and Farmer Bob have rectangular fields that are the same shape. Farmer Joe's field has a perimeter that is 2 times as large as Farmer Bob's field. What is the ratio of the area of Joe's field to Bob's field? So we know that the perimeter of Joe's field is 2 times as large as Farmer Bob's field. So that means if Farmer Bob's field has width W and length L, then to have the perimeter for Farmer Joe's field 2 times as large as that, then that means the width and the length have to be 2 times as much as well. Okay? So what's the area of Farmer Bob's field going to be? Well, it's just W times L, right? What's the area of Farmer Joe's field going to be? That's 2W times 2L, which would be 4WL. Okay? So as you can see here, 4WL is 4 times as much as WL. So Farmer Joe's field is 4 times as large as Farmer Bob's field, making the ratio 4 to 1. Okay? So for the next question, the median of a triangle is a segment that connects one of the vertices to the midpoint of the opposite side as shown. Okay, so the median would be from M to B in this example. So if the area of triangle ABC is 36 units squared, what's the area of triangle ABM? So how do we find this? Well, we know the area of the whole thing. The whole thing, 36. So how do we find the small ones? Well, as you can see here, if we have ABM and BMC, both of them have the same height. They have the same exact height because their tips meet at the same level. So they have the same heights. And they also have the same bases because the median is going to cut AC in half, which will make AM congruent to MC. So not only do these triangles have the same height, they also have the same base. So that means that their areas are going to be the same as well. So these two triangles have the same area, area A, and combined together, they make 36. So each of these triangles will have half of 36, 18 units squared. Okay, any questions? All right, cool. So now we have circles. We're going to be talking about perimeter and area questions about circles. So we know what circles are. Circles are just these curved shapes, right? This is a circle. So how do we label the parts of a circle? Well, if we put a dot here at the center of the circle, this is called the center of the circle, right? And now if we connect the center to the edge of the circle, this is called the radius of the circle. And the radius will be the same amount throughout the whole circle. Okay? So we label that as r, radius. Another part of the circle we can look at is the diameter. The diameter is if we were to pull this and go out to the other end, making the entire thing the diameter. Let me write that out, diameter. Okay, so these are two words that you should remember. The radius of a circle is from the middle to one of the edges. The diameter is from one edge to the other edge. Okay, so what's the perimeter of a circle? Well, the perimeter of anything is going to be the length of this path around it, right? And the perimeter of a circle is given by 2 pi r. R is the radius, and 2 is 2. But what is this thing? This thing is what we call pi. Pi is a number that we use a lot in math. And this number basically relates a bunch of things that go on with circles. And this number, if you want to have a close estimate, it's around 3.14. But this number will go on forever. This number goes on forever and ever and ever. Okay? So if we multiply this number by 2 and the radius, we'll get the perimeter of the circle. And for a circle, we actually don't use the word perimeter. We use a special word called circumference. The circumference is basically the same thing as the perimeter of a circle. Okay? And the circumference is given by 2 times pi times the radius. All right? So in most cases, you don't need to write out pi as 3.14. For example, if the radius was 3, then you would just write the answer as 6 pi. That's perfectly fine. Okay? So now what is the area of a circle? The area is the inside of it. The area, we use pi again. The area is given by pi times r squared. So we first take the radius in square, and then we multiply that by pi, and that's going to give us the area of the circle. So once again, if the radius was 3, then we would have 3 squared times pi, 9 pi, and that would be the area. Okay? And we have a lot of common problems with circles, such that you might have really weird areas. Like if we had this and this, some problems will ask you, hey, what's the shaded area of this? Well, the trick to solving these kinds of problems is to take the big circle, the area of the big circle, and subtract out the area of the hole here, the small circle. Okay? So that's the trick for these types of problems. We do not know how, there's not like a formula to find the exact area of this shaded area here, but we can take the big one, subtract out the small one, and that's going to give us the area of this curved shape. Okay, so that's more like a problem-solving technique that will be very useful later on. So let's do some problems with these. Okay. So once you get your answer, please chat that to me. I'm going a little low on time, so maybe 2 minutes for these. So what I really want you guys to do is look at the second problem. Try to figure out how you would go through solving that, but don't worry about solving it yourself. So pi in this case will be pi. You can't really type out pi from your computer keyboard. Okay, how about 1 more minute, because I'm running a little low on time, and I want to get through everything I need to get through. So for these kinds of problems, you don't want you want to give the exact answer. If it doesn't tell you that you should round it to any type of number, if it doesn't tell you to, like, for example, round to the nearest tenth, then you have to give your answer in the exact form by writing pi in there. Okay, so that's something you should look out for. All right, so I'm going to go through these problems now. I'm running a little low on time. So a circle has circumference 54 pi centimeters. What's the radius? Well, circumference, once again, is given by 2 times pi times the radius. Now, if we plug this into the formula, we get this equals 54 pi. 54 pi. Oops. So we have a pi on both sides. We can just cancel those out. 2 times r equals 54. So r will equal to 27 centimeters. Okay, that's the radius. So now the next problem. My rectangular house is 30 feet by 40 feet. My dog is on a 50-foot long leash outside and she's tied to a corner of the house. What's the area in the region where she can walk around? Well, let me draw out the house here. We got 30 feet and 40 feet. And we've got a leash that's 50 feet long. Well, the leash will basically act as a radius of the circle in which the dog can roam, right? The leash is basically going to make a circle like this. All right? But then when you get here, the leash gets bent, right? It gets bent. And now we only have 10 here. And then the leash makes a smaller circle with radius 10, a quarter circle like that. And similarly on the other side, let me get this out of the way. Once it gets here, we only have 20 left, so it can't make a circle of 50 meters. And it rounds like that. Okay, does everyone get how this works? Because when you hit the wall here, the rope is going to bend. It's going to bend so that its radius is only going to be 20 now. Okay, so basically how would you find the area? Well, this is just a big quarter circle of radius 50. A big quarter circle. A big 3/4 of a circle. So this would just be 50 squared pi times 3/4. And then we would add this to the small areas here. We have 10 squared pi. And this is a quarter of a circle. We divide by 4. We have another quarter circle here with radius 20. Okay, so if you would solve that, you would get your answer. Okay, so this problem you're actually going to see a lot in your future math problems. So try to keep this strategy in mind. Okay, any questions? All right, now we have one last problem here before we get to the quizzes. This is quite a challenging problem. Okay, so I'll give you maybe, how about 1 minute to think it through and think about the strategy in solving for this problem. Okay, you don't need to actually solve it. Just think about how you would approach this problem. How would you find the area? Okay, and then I'll tell you the solution. So you don't need to actually calculate the number. All right? Because I'm running a little low on time. So once you get the idea in your head, how do I solve this? Once you have that idea, then when I explain it, you can check and see if you were right. All right, how about 10 more seconds of think time? Okay, so 2 quarter circles are drawn with their centers at opposite corners of the square as shown. If the side length of the square is 6, what's the area of the shaded region? Well, this region looks like kind of like an eyeball, right? Well, there's not really an exact formula for how to do this problem. So how do we find it? Well, one thing we can do, let's first cut it in half. Let's first cut this shape in half. Someone's raised their hand. Do you have a question? All right. So if we cut this in half, we only have 1/2 of this. All right. So how does this look? Well, if we draw the quarter circle again, this is this shaded area, right? This is 1/2 of what we really need. So how do we find this area? Well, we can take the entire quarter circle, the area of the entire thing, the area of this, and subtract out the area of the triangle here. right? And that will give us 1/2 of what we need. So what's the area of the quarter circle going to be? Well, one whole circle, well, this is a quarter circle with radius 6. So one whole circle would be 36 pi. One quarter circle will be 9 pi. We subtract this triangle out of here. We have a base and height of 6. So the area is going to be 6 times 6 divided by 2, 18. So this will be the area of this part. So now all we need to do is double this value to get the area of the entire eyeball, right? So what's this going to be? 9 pi minus 18. We just need to double this. 18 pi minus 36. Okay? So this is basically the approach to a problem like this. You try to manipulate the area so that you can try to add or subtract things together to get the area you need. All right? So now we've got quizzes. So I'm going to stop sharing and share the quizzes here. So where is the quizzes? Quizzes is here. All right. So let me pull up this quiz. Can everyone see my screen here? All right.
Yeah.
So joinmyquiz.com. Let me share the link in there. Into the chat. Here's the link. Click on that direct link to get you to the quizzes, or you can go to the quizzes website, type in the code 366374. Oh, look, what's this? Quadratic formula. All right. So, is anyone having trouble getting in? Or is everything okay? I think I'll take that as a yes. So, about 30 more seconds to get in the quizzes. Normally we have like 26 people. So before we start, just a reminder, no calculator is allowed on these, okay? Just to keep it fair. And also, don't try to speed everything, okay? Quizzes prioritizes a correct answer over an incorrect answer. So even if you take longer on a question, as long as you get it right, you're going to get some kind of amount of points. But if you rush and you get it wrong, then you get 0 points. Okay, that's just a quick quizzes tip over there. I'm going to get started now. 3, 2, 1. All right, good luck, guys. You guys are doing pretty good. Melanie. Third place, Bobby. Fourth place, Jonathan. Fifth place, Andrew. Adolf now climbing to first place. Whoa, there's a fight for first place right now. Jonathan with a perfect game of 7 so far.
I got fifth place. Not bad, right? Fifth place.
Standings now. First place, Bobby. Second place, Jonathan. Third place, Adolf. Fourth place, Melanie. Fifth place, Gavin.
I got this question wrong.
Alright, 3.141592653585779. Now moved up to fifth place.
What percentage of U.S. adults think that chocolate milk comes from brown cows? I'm
Yep,
kidding.
that's
That's
a
not
trivia
bad.
question.
Sure. Yeah. Yeah. The true or false? 7% of adults think that chocolate milk comes from brown cows. True.
Adolf now in second place. Jonathan, second place. So I hope you guys enjoyed that trivia question. What is it? 7% of
I'm
US
sixth
adults
place.
actually do think that chocolate milk comes from brown cows. Yes, that is a true fact. So, yeah. Americans are, I guess, they don't know that much about how chocolate milk works.
It's just milk. And then they add chocolate.
Adolf with a streak of 8 correct answers. Now in second place.
They're good.
Smiley face has taken the number 1 spot. As you can see here, people who finished quickly did not do as well as those who are taking their time. Right? As you can see, the top few people are not done yet. So that is the strategy. You have to take your time. Make sure you get those right. Okay, so if you finished and you want to leave now, feel free to do so. But if you'd like to see who gets the top 5, then you can wait just a little longer for them to finish. So if you must leave right now, you can go ahead and leave. Autumn now with 9 correct answers, a streak of 9. It's the highest overall on the board. spot off. 5th place, Melanie. And yep, let me put that in the chat here. So what are the scores going to be? Alright, so those are the top 5 now in the chat. So I'm going to end the game now. The top 3 are 3rd place, Bobby. 2nd place, Jonathan. 1st place, Smiley Face. I don't know who that is, but well done, guys. Alright, so I hope you enjoyed class today. Good job to the top 5. And I'll see you guys next time. See ya.